All right, so this one is, what did you all think of this particular problem?
Still struggling with it.
Yeah, it's much more open-ended than a lot of problems we've given you so far, right? So let's work through this bit by bit together and try to get a working structure out of it. So we can see our summary. I Heart Ice Cream is a creamery that makes delicious ice cream. They are growing rapidly and they need some software to help them manage their kitchen. Our job is to build a program that will help them manage their ice cream freezing. Here are a few user stories to help us get started. As an ice cream maker, I want to make different types of ice cream, peanut butter, chocolate chip, etc. As an ice cream maker, I want to place batches of ice cream in a freezer. And as an ice cream maker, I want to know when a batch of ice cream is ready to be removed from the freezer. And really 0 here, we have to design the structure. So we have to think about this problem critically before we even begin to write code and describe how we would design the program in plain English. And here are the questions we need to consider. What are the essential classes? What attribute does each class need to have? What interface will each class provide? How will the classes interact? And which classes will inherit from others, if any? So I'm going to open this up. So let's plan this out. What classes do we need? 2 of them have been provided to us, but we can always add more if we need to. So we've already been given ice cream and freezer. Are there any other classes we think might be useful here?
I created a tracker class to track all the freezers and ice cream in the freezers.
Okay, so we could have a tracker class. Does anyone else have any classes that they think would be helpful or necessary for this? All right, there doesn't have to be. All right, and then let's talk about attributes. What attributes does ice cream need?
Flavor.
Yeah, it needs a flavor. We can take a look again. So we need to know essential classes, attributes, everything like that. All right, what else does ice cream need?
How many hours it's been in storage.
Okay, so we could say, time stored. Anything else?
Form.
Form. What do you mean by form in this case?
Like
sense?
liquid,
Mhm.
frozen, super frozen, stuff like that.
Yeah, form, and I believe later on they use the word status, which I think means the same thing. So I'm gonna change that to status just because form. Whenever I hear form, I think of like a form to fill out, and I want to avoid confusion that way. But thank you. All right. Anything else? Flavor, time stored, status.
I did a type for like sorbet or yogurt or ice cream.
Sure.
Because I mentioned something about different freezing times for different types of ice cream.
Yeah, we can definitely do that. All right, let's talk about freezers then. What attributes does a freezer need to have?
Its contents.
Contents. So how many? So those are the ice creams, right?
Yeah, just like an array of what's inside it.
So you can call them contents or ice creams.
A capacity amount?
Yeah, max capacity. Anything else?
A function to put stuff inside the freezer.
Yeah. Right now we're just talking about attributes, but we are going to need that. All right, well, I think we can just deal with contents and ice creams for now. And Emma, you created a tracker class. What did the tracker class have?
It had a class variable that was a list of all the freezers that it created.
All right, so list of freezers. Anything else? That's it? Okay,
Are we talking about just the variables for now?
yeah, just the attributes. Mhm. Okay, so we have a structure here, a very small structure. So let's get that made. So we need to have def in it for all of these. And an ice cream, so we know it'll be, it has to be initiated with a flavor. Does it need to be initialized with a time stored status or type? Maybe a type as well, right? If we're talking about this could be sorbet or gelato, etc. Self.flavor equals flavor. Self.type equals type. Time stored would start at 0, I'm assuming. And maybe the status starts, I believe they have a list of statuses here. Watery, almost ready, ready, and freezer burned. So we could say self.status equals watery. How does that look? Does it seem like the ice cream thing is ready to go as we wrote it?
I think so.
I used a dictionary as a class variable to have all the stages, and you can just increment the key by 1 to move it to the next stage.
Okay, so just want to make sure. So you have something called like stages, and you used a dictionary.
A dictionary, yeah.
So you'd have like
0 is watery, 1 is almost ready, 2 is ready, and 3 is freezer burned.
so it was watery, almost ready, ready, and freezer burned. Quick question. So if we have a dictionary and all of the keys are numbers, we've kind of created another data type, right? Data structure, right? Because what's the
Isn't that
other?
an array?
Yeah, an array
An
pretty much
indexed
operates the
array.
same way. Is it would have the keys are all index numbers. So I think we could actually kind of refactor this from a dictionary to an array and would make the same, it would be the same thing. So watery, almost ready, ready, and freezer burned. Does it make sense why I'm changing it this way?
Yeah.
Okay, let's move on to freezers. So we said a freezer would have contents, meaning how many ice creams it would have, and a max capacity. So I imagine we'd probably want to tell it what the max capacity is here, because you could have like different sizes of freezers when you buy a new one. You can say self.maxCapacity equals max capacity, and then self.ice creams could just equal an empty array for now. Then we could say class tracker. So right now it just starts with how many what freezers are in it. So self.freezers.
I made it a class variable too, so you can access it, all the freezers that you have.
Mhm.
I guess you're only creating one instance of it, so it wouldn't matter. But if you happen to have more than one store, maybe, or something.
Yeah, in general, I would say if a tracker is supposed to represent, okay, this is one thing that tracks multiple freezers, I feel like freezers would make more sense as a instance variable here because each tracker has its own freezers to keep track of. But yeah. Okay. What questions do you have about how we've created these classes? Does this all make sense so far?
Yes.
Okay. So now it says we need to implement a minimum viable product. It does not need to track multiple types of ice cream, but you should be able to move ice cream into and out of a freezer. And it says this would be a great time to write some tests in the spec file that show how you'd like your classes to work and then get them all to pass. That's a great idea. So let's think about this then for a bit. We have ice creams and freezers. How do we want them to interact?
The freezer will be filled with ice cream objects.
So we need to be able to load ice creams into and out of a freezer then, right?
Yep.
Okay. So we can say, def test load ice cream into freezer. We could say, all right, we can make a new ice cream equals, it's a new ice cream. We can say this one is chocolate, gelato. We can make a new freezer, oops, equals a new freezer with a max capacity of 5. All right, so what should we call our method to load ice creams into a freezer? And should that belong to the freezer object or the ice cream object?
The freezer.
Yeah, makes sense. The freezer is the one who has to keep track of, I need to be able to load in an ice cream into me. So maybe we could call this one, freezer dot load ice cream. And we're passing it in the ice cream. And how do we know that it's worked the way it's supposed to?
We could check the amount of ice cream it has in it.
Yep. So we could say something like self.assert equal, and it'd be freezer, so it'd be len freezer.icecreams and 1. We could also do something like this. We could say self.assert in. We want to check that ice cream is in freezer.icecreams. Self.in, assert in, that is, checks if this is in this particular thing. Okay, cool. So that's one way we can test how they interact. What's another? What else? How else should they be able to interact?
Remove an ice cream.
Yeah, we should be able to remove ice creams. Test remove ice cream. And we can even just copy all of this and just say, we create an ice cream, we create a freezer, load the ice cream into the freezer. And then we could say freezer.remove ice cream. I guess we'd want to be able to remove that specific ice cream. And so then we could say self.assert equal len of freezer.ice creams and 0. That makes sense to me. All right. How else should they be able to interact? So we can move ice cream into and out of a freezer. That's really all it says we have to do for now. So maybe we can start, keep with these tests and then add more tests as needed. So I do Python ice cream and freezers spec. We run 2 tests that both fail. So we have 2 methods that we need to create, the load ice cream method and the remove ice cream method. So we could say def load ice cream. It needs to take an ice cream object as its arguments. And here I think, well, what do we have? This should be a pretty simple method, right? You just say self.icecreams.append ice cream. All right, then we need to have one called remove ice cream. That says we remove a very specific ice cream object. So how do we make sure we only remove that particular ice cream object from our list of ice creams?
You pop it at the index of the hash
The
that
hash?
is stored in self.icecreams, I think.
So we have, I just want to, so when, so you said pop it at the index of the hash that we have in self.icecreams, is that what you said?
Yes.
Okay, what's the hash here?
It will be the index of ice cream in self.icecreams.
Okay, yeah, so it'll be the index of the ice cream we want to remove. The question is, okay, we need to remove that, we need to figure out what that index is. Because the way it's written right now, remove ice cream, we give it an ice cream object to remove, which doesn't tell us what the index number is. So we'll need to figure that out.
Can you do ice creams.remove?
Ice creams.remove. So self.icecreams.remove. What does remove do?
I think it pops the first element that you give it in the argument. It'll pop the first element from ice creams.
Yeah, let's try it. So if I run my tests, they both pass. Okay. So we were able to put ice cream into our freezer and remove it. That's cool. So let's take a look at additional features here. So we have multiple types of ice cream, each with a different freezing time. Status attribute for ice cream with at least these possible values: watery, almost ready, ready, freezer burned. So, all right, so different types of ice cream with a different freezing time. We didn't really implement that, did we? We have flavors of ice cream and types of ice cream and statuses. We have a time stored, but we don't have a freezing time. So let's see, how can we do that? If we want to say, okay, if the freezing time is based on the type, how can we determine what the freezing time is based on the type?
I used a dictionary of dictionaries.
Yeah, and we could definitely have freezing time times equal dictionary. And I was thinking we could do something like, okay, gelato has a freezing time of 10. This is all arbitrary. Sorbet has a freezing time of 12. Frozen yogurt has a freezing time of 8. And I don't know, what other types of ice cream are there? Custard, freezing time of 9. Oh. And so once we have the type, we could say something like self.freezing time equals, this would be ice cream dot freezing times at the key of what class we're in, of the type. And so we have time stored, and we can always compare that to our freezing time now. All right, so now we need to be able, so we have time stored and freezing times. There should probably be some way that these can interact with a method, right? How would we be able, so let's make a method and write some tests for it for freezing an ice cream. Like test chill ice cream, let's call that. We could say, okay, ice cream is a gelato. What method should we make to freeze it?
I used a freezer method that would freeze all the ice creams, and like each ice cream has, so the ice cream has a freeze method, and then like a freezer calls all the ice creams freeze methods.
Cool. So that makes sense. So a freezer would be able to tell all of the ice creams to freeze. So we can call this one ice cream dot freeze. And should we give it like a specific, should it take an argument or should it just be argumentless?
I added an argument just if you wanted to be variable with your time.
Yeah, so we could have that be how much time it is. So we freeze it for, well, let's actually just say, yeah, if we wanted to freeze it entirely, so we could give it 10, that's what we said for gelato. And how do we know that it's worked? So if it has a freezing time of 10, and we freeze it for 10, what should happen at the end of it?
Status change.
Yeah, so we'd want to say, all right, self dot assert equal, we could say ice cream dot, first we could say time stored should also be 10. And we should say self dot assert equal ice cream dot status should be ready at that point. Okay, so let's make that method. So we could def freeze. That takes self and time as an argument. Okay, so we know that the time stored should be increased by time. So plus equals time. All right, so now we have the kind of tough part of figuring out, okay, how does the time stored relate to the status? Because at this point we've got stages here, and the stage, like what stage you're at is going to be different depending on what type of ice cream you are, right? So how are we going to, how do we determine the relationship between time stored and stage?
Well, you could just create some sort of arbitrary split between your freezing time, like within your freezing time. So like if you're a quarter of the way through your freezing time, you're almost ready.
Yeah, so we could do some mathematics here. So what I'm thinking is, okay, we've got watery, almost ready, ready, freezer burned. Ready should be if it's at the freezing time. Freezer burn should be anything above that. So the question, so really we just need to determine between watery and almost ready. We break it down that way. So let me think about that. So we could say self.status equals, then we need to do some math here in our stages thing. So we could say, if we do self.time stored, rounded down, divided by self.freezing time. So let's say if our time stored was 8 and our freezing time was 10, 8 divided by 10 round down would be still 0. Okay, so that's not quite right. So what's another way we could do this?
You just use like floating math and then to determine some percent, like what you want to be as your almost ready time.
Yeah, so we could do something like, all right, so percent we're at, like the percent we're at could equal, there'll be self.time stored divided by self.freezing time. And if we wanted to actually make this a percentage, we could multiply that all by 100. And so then we could say something like, if percent equals 100, self.status equals ready. So in this particular version, I'm kind of not using the storage thing at all here, the data storage. But I'm assuming this will work. If percent is greater than 50, self.status equals almost ready. Actually, I think I want to do, if it's greater than 100 first, we'll do freezer burnt.
You could still reference that that class array and just use the indices instead of typing out the names here.
Yeah, so I could do self.status equals, what did we call this one? Stages. So ice cream dot stages 2. If percent is greater than 50, stages 1, else status equals ice cream dot stages 0. Okay, so in this case, I'm kind of hard coding it in a bit but this algorithm here of saying, okay, how much percentage we're at should in theory work for us. Let's try it out. Okay, passed the one test, which is we were able to get it. If we stored it for 10, it was ready. So maybe we should test it for the other statuses too. So we could say right here, self.assert equal ice cream.status at the beginning should be watery. All right, and let's try freezer burning an ice cream and see if that works. Oh, test freezer burn ice cream. And if we freeze it for 20, I should assume that the status should be freezer burnt. Uh-oh, we had a failure. Oh, freezer burned is how we put it earlier. Okay, what questions do you have about what we've done so far? I'm not saying all of
The
this is...
freezing time right now, so when you put in a freeze method, if you have more than one ice cream and you do a freeze, it's gonna freeze them all at the same time, right?
Yep.
Okay.
And yeah, so we can actually even get to that, right? So the freezer method should be able to say, all right, I should be able to tell all of the ice creams to freeze for a certain number of time. So if I say freezer.freeze for 10, every ice cream should be frozen for 10. So let's write a method to test that. Test freezer freezes ice creams. And I'm just going to copy some of the code. And let's add 2 ice creams into there this time. We can make a vanilla, and this one can be a sorbet. There's such a thing as vanilla sorbet. Orange sorbet. So we can freezer.load ice cream 1 and ice cream 2. And then we should be able to say freezer.freeze for, let's just freeze it for 5. And how will we know this works?
I can't remember the variable we used, but just check each ice cream's like time frozen.
Yeah, I think we use time stored. So I should be able to see self.assert equal ice cream.time stored should be 5. And the same thing should be true of ice cream 2. Okay. So we can make our method. It's going to take self and time as an argument. And so then we could probably use a for in loop to go over our ice creams array, right? So we could say for ice cream in self.ice creams, ice cream.freeze for time. So remember what I talked about earlier about the law of Demeter and these methods knowing as little about each other as possible? So in this case, the freezer freezer class knows that each ice cream is going to have a freeze method, but it doesn't need to know anything about the ice cream's time stored or status or freezing times or anything like that. All it knows is the freeze method, and that kind of serves as the only bridge between them. So stuff like this is how we kind of make sure that our methods know as little about one another as possible, and why it's always good to wrap these things in methods when it, like wrap attributes in methods whenever you want to change them, because that way you're kind of controlling, kind of the flow of how these things work together. So I'm going to try running the test. All of our tests pass. Okay. So what else should a freezer be able to do? Right now, it can load an ice cream, it can remove an ice cream, and it can freeze those ice creams.
Run out of space.
I'm sorry?
Run
Run
out
out
of
of-
yeah.
So we can actually add that to our load ice cream thing, right? Saying, okay, if there's too many ice creams, we need to remove it. So we could always say something like, if the length of self.ice creams is greater than or equal to self.max capacity, we could raise an exception of this freezer is full. Shouldn't we should be able to check on the ice creams, right? Look inside essentially and see, how each one is doing. So we can make a method called something like, let's call it like, what the heck? We could call it test freezer status report. And we can, I'm just gonna, copy all of this code here, which is not very dry, I know. All right, and so then we should be able to run the status report function. And what should that be? What should that tell us?
Iterate through the ice creams and give a status.
Yeah, it should tell us the status of each of the ice creams. So maybe maybe it can like print out a nice string for us. So we could say, self.assert equal ice freezer dot status report. And then we need to figure out, okay, it needs to something like saying, so if we freeze them both for 5, just want to, say, okay, they should both be. So at that point they should both be still watery. So we could say something like the chocolate gelato is watery, the orange sorbet is watery. Does that make sense? How we want to do that? Okay, so we can make our method. So we could say def status report. And we could create a report which equals an empty string. Then we could say for ice cream in self.ice creams, report.append the, so be ice cream dot flavor ice cream dot type is ice cream dot status period space, something like that. And then we return the report at the end. Let's try this out. Uh-oh. All right, we can't append with a string. I'm thinking of, so would it just be report plus equals? All right, so we have a problem. It says that the chocolate gelato is watery, the orange sorbet is watery, does not equal the chocolate gelato is watery, the orange sorbet is watery. Does anyone see the difference between these two strings?
We're adding a space at the end of
Yep.
our string.
Yeah, we have that extra space at the back. So we need to make sure that we only do that when we don't do that when it's the last one. So I wonder if Python has a way of because a lot of languages have this. Python remove trailing white space. Okay, so it looks like there's a method called strip. Let's take a look at that in more detail. So remove spaces at the beginning and end of the strip, end of it. Okay, so we could say, doesn't say if it's a, so we could say return report dot strip, which should remove any trailing white space. Okay. What questions do you have about status report? So one thing I don't like about this method is in order to do that, the freezer needs to know that each ice cream has a flavor, a type, and a status. So what if I gave the ice cream a method to report its own status? So call this one, report status, and say, self, and just return the self dot flavor self dot type is self dot status. And then if I did that, I could just say report plus equals ice cream dot report status. So that way, if I decide to change what my variable names are in my ice cream class, the freezer class won't be affected as long as it still has that report status function. And it still runs the way it's supposed to. All right. What other questions do you have about ice creams and freezers? So I know we didn't get to the tracker class, and I can definitely see how that would work very well. I just wanted to make sure that we focused on these two classes first, and I don't want to go too long because we also have to talk about today's lesson. So one last stop for questions before we take a break.
I actually have one quick question. In all these methods, if we're not returning anything, is it better to put return none rather than not have a return statement at all?
Good question. Generally speaking, yeah, your method should usually return something. If it doesn't, but it still does what it's supposed to, it's not going to be a huge deal, but it's always a good idea to make sure you return, do that. So maybe for freeze, for example, I want to say, okay, at the end, it should return the self.status just so that it does return something. And then you could say, hey, what is self. If I call ice cream.freeze, it'll return its status at the end. Good question. Yeah, it's generally better to return something when possible. But I think it's not going to be a huge deal if you're not returning something, if it doesn't make sense to. Okay. Any other questions? Okay, in that case, let's take a 10-minute break. So be back here at 10:02, and we'll get to talking about CSVs.